Okay, welcome back. Today we are going to talk about systems of equations again, and we're going to solve algebraically, but instead of doing substitution, which we did last week, we're going to talk about the second method of doing them algebraically, which is called elimination. Okay, so in substitution, you always had equations that said either y equals a value or x equals a value, and you substituted it in. In elimination method, you're not going to have those equations that say y equals a number or x equals a number. So I'm going to show you another option. Okay, first things first, we're going to use a little prior knowledge to help us moving forward with elimination. And what these problems say is multiply one or both of the following in order to make opposite numbers in the pairs below. So I have the pair 6 and 1, and I notice that they're both positive, so they're not opposites yet. So I need to multiply one of these values by a number, and I'm going to multiply the bottom number so that we get the opposite. So if we have 6 here and we have 1 here, we can multiply the bottom number by negative 6. Positive 6 there, negative 6 times 1 would be negative 6. And now these are opposite numbers. When we move on to the next one, we have a positive 8 and a negative 4. The fact that it's positive and negative, we already have opposites. Now we just have to get them to the same number. So again, I'm going to multiply the bottom one. And if I have a positive 8 up top, what can I multiply by negative 4 to get a negative 8? I would multiply it by 2. So 2 times negative 4 would be negative 8. In our third pair, we have a negative 2 and a positive 3. Again, one negative, one positive, and we need to come up with a common number. Well, the way that you do that, if you don't have one like we had in the past where you just have to multiply one, the easiest way to do it is multiply the top number by the bottom and the bottom number by the top. 3 times a negative 2 would be negative 6. 2 times a positive 3 would be positive 6, and now we have our opposites. And the last one that we have here is we have a positive 7 and a positive 2. Again, they're both the same sign, and they don't have any common numbers. So in this case, you're going to pick one, and I'll pick the top, multiply it by a negative 2, which would give us negative 14, and the bottom by a positive 7, which would give us positive 14, and then they're going to eliminate themselves. Okay, so that's the goal when you're dealing with elimination, is to get opposite numbers with one of your sets of variables. So let's look at these words. It says elimination is typically used when you are given two standard form equations. The goal is to eliminate one set of variables for the other, solve for the other, and use that value to determine the second coordinate. Kind of like what we were doing up here. Then you may have to modify neither, which is what we're going to do today, one, which is what we're going to do tomorrow, or both, which is what we're going to do in a couple of days, both equations to solve. So let's look down here, and we have 3 examples. I'm going to do 2 of the examples for you, so you can copy down and observe, and then you're going to do the third example for homework. So the first example, we have 2x plus 3y equals 12, and 5x minus 3y equals 9. Again, the goal is to find variables that are opposite numbers, opposite coefficients. So I have a positive 2x and a positive 5x. They're not opposites. I have a positive 3y and a negative 3y. These coefficients are opposites, so those are the ones that we're going to eliminate. So we're going to draw an equals line, and we're going to add the equations together. 2x plus 5x is 7x. Positive 3x plus a negative 3y, they eliminate themselves. So we're done. Equals 12 plus 9, 21. Then we're going to solve for x. Divide by 7, and you get x equals 3. And that is the first coordinate in the solution. Just like when we did substitution, as soon as we found out what x equaled, we're going to substitute it back into one of the original equations. Take your pick. I'm going to do the top one. So 2 times 3 plus 3y is equal to 12. 2 times 3 is 6 plus 3y equals 12. Subtract 6 from both sides, and you get 3y is equal to 6. Divide by 3, and you get y equals 2. So there is our second coordinate. So what that means is our solution is 3, 2. And what that means is that if we were to graph these two lines, they would intersect at the point 3, 2. I'm going to highlight the solution in green. I hope you can see it. The next one we're going to look at, we are going to do the exact same thing we did in the first. So we have 6x plus 3y equals 48, and we have negative 6x plus 4y equals 50. So we want to eliminate one of the variables. Okay, so positive 6x, negative 6x. We can eliminate our x's, so I'm not even going to look any further. So we add both equations together. Positive 6x, negative 6x cancel out. Positive 3y, positive 4y is 7y is equal to 48 plus 50 is 98. Solving for y, we're going to divide by 7, and you get y is equal to 1, 4. Use a calculator for these if you can't do that in your head. So the first coordinate that we solved for is y, and that's 14. And then again, once we figure out one value, we're going to go back up to either the first equation or our second equation and solve for x. So 6x plus 3 times 14 is equal to 48. So we have 6x plus 3 times 14, 14, then 28, then 42 is 42 is equal to 48. And then subtract 42 from both sides. You get 6x is equal to 6. Divide by 6. X equals 1. So again, we have found our second coordinate, x equals 1, and we're going to put that into our solution. And our solution would be 1, 14. So if we were to graph these two lines, boom and boom, they would intersect at the point 1, 14. Okay? The last equation is right here. I would like you to solve this equation for homework. Bring it in tomorrow. Okay? Have a great night. If you're confused, go back and watch the video again. A student told me the other day that it really helped her when she went back and watched it for a second and third time. Have a great day. Take care.